This is our tutorial on interpreting solutions to real-world systems. Last time we looked at just uh, finding the solutions to systems of equations from a graph, and this time we're doing that as well as interpreting them given a real-world scenario and a graph that goes with it. So our first example, Wash Tub, which is graphed as graph A, and CarWorks, which is graphed as graph B, both offer an annual car wash membership. With this membership, customers pay a one-time fee that entitles them to a reduced price of car washes for 1 year. The graph at the right compares the two plans. What is the point of intersection? Remember, the point of intersection, or the point where the two lines cross, that is the solution. So if we're just trying to find the solution, it's the point where the red graph and the purpley graph cross, which I'm going to highlight here in green, right here at this spot. And I'm going to label that. That is our solution. And then I also need to give the coordinates. So I'm going to come over here and I'm going to get my coordinates. Remember, it's x first, y second. Our x-axis is the one on the bottom, the horizontal axis going side to side, so I need that number. So I'm going to draw a line down. And if you can see it, I'm going to count it from the origin of 0, and this is going up by ones. 1, 2, 3, 4, 5, 6, 7. That's at 8. So I'm going to put an 8 over here. And then I also need the y number. The y-axis is the vertical up and down, so I'm going to draw the line across to there. And again, I'm going to start at 0, but I'm going to notice this axis is going up by tens. So this is 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So that's at the 100 spot. So my point of intersection, or my solution, is the point 8, 100. Now, what does that mean? Because this is a real-world type situation, so those numbers have meanings. The first thing I'm going to do is look at what does the x number mean. And I'm going to notice that the x-axis is labeled as the number of car washes. So then that means that that x number there, which goes with that red graph, so I'm going to do this one in red, that 8 is car washes. Okay, and then I'm going to come over here and look at what does my y number mean. I'm going to do that in a different color, and I'm going to notice that my y-axis, the vertical up and down one, is charged in dollars. So that 100, which since that's a purple, I'm going to use the blue, that 100 is actually money, or it's dollars. I'm going to put a little dollar sign there. And then when I sort of write what it's about, I can notice that that spot is the one spot that both of those lines share. That's why it's a solution, where they cross. So it's the one spot that they have in common. And what that means is that for 8 car washes, both places charge $100. At any other time, 1 car wash, 2 car wash, 10 car washes, any others, at any other time, they charge a different amount. That's the one time where they charge the same amount for the same number of car washes. Now I'm going to look at the second example. This one says, Bert and James have motorcycles. Bert's gas motorcycle has a gas tank that holds 5 gallons of gas and averages 35 miles per gallon. And I'm going to notice that of the two graphs, the one at the top starts at the 5. So this one right here, that's Bert. And then it says James's motorcycle has a gas tank that holds 3 gallons of gas and averages 70 miles per gallon. So I'm going to notice that here is the one that's got the 3 on the gallons of gas. So that must be James. So I'm going to label Bert and James. And then it says complete the table and make a graph to show the amount of gasoline in each motorcycle's tank after filling up and then taking a road trip. This system has been graphed below. Well, we've already got the graph, and we're not really going to worry about the table today. That's going to be on a different one. But what we're going to look at is just the point of intersection and what does that mean from the graph. So once again, I'm going to highlight this intersection point is where they cross. And on a system, That spot is referred to as the solution. And I'm going to give the coordinates. Now remember, it's x first, y second, and my x-axis is the across. I'm going to come down. That's at 140. And then the y is the up and the down axis over here, and that's at the 1. And that's the one spot that they have in common. And then again, I'm going to use my highlighter where I'm looking at what does this mean. I'm going to notice that this x-axis over here is the miles driven. Okay, so I'm going to come back to that 140 number. That was my x number. And I'm going to label that that is miles. Okay, then I'm going to come back over here with my highlighter, and I'm going to highlight that the y-axis is the gallons of the gas. I'm going to do that one in red. So this 1, which is a y number, that's 1 gallon of gas. And that's actually left in the tank, because you can see that the lines are going down, indicating that the gas is being used up as they drive more miles, and that seems to make sense. Okay, so what does this mean? Well, when they have driven 140 miles, they both have 1 gallon of gas left in their tank. I'm going to write that down. At all other times, one of them has more than the other. Either James has more in his gas tank than Bert, or Bert has more in his gas tank than James. But at exactly 140 miles, they both have 1 gallon of gas left. And that's what that solution means. So the key to this is not only being able to pick out the solution, but use what your X and your Y axis labels are so that you can tell what those numbers are actually referring to. Like 140 was miles and 1 was gallons of gas left.